Good morning to everyone. Myself, I am J. Charan from Triple E branch. Today's my topic on chemistry is a new method forming ZNT contacts for CDT cells of solar cells. Studies of ZNT bank contacts and CDT solar cells. Recently, advances in the CDT technology made CDT a great candidate for commercial thin film solar cells because it is used in infrared windows for optoelectronic devices such as photovoltaic ones. Nowadays, solar cells with nanometric thicknesses are increasingly required due to an enhanced behavior effort. It is common to observe interdiffusion phenomena during several technological processes that are required for the fabrication of photovoltaic devices. It is very important to note that this interdiffusion could strongly affect the final efficiency of devices. In this work, the study of two materials as an interlayer between the CDTE thin film and metallic contact is presented. Here we can see the two materials as an interlayer between the thin film and metallic contact is presented. TE and ZNTE were deposited on the CDTE surface by using a closed space sublimation technique. The electrical properties of the device were evaluated after 2 and 4 years to observe the electrical behavior of TE and ZNTE layers implemented as part of the back contact. It is commonly known as the CDT technology has been studied for a long time, reaching record efficiency of about 22.1% and established procedure for the CDT solar cells development is an enrichment of CDT by TE. This is fundamental to form a stable telluride compound with copper from metallic contact. Thus, we can get an ohmic and therefore a low resistance back contact. Some researchers use a ZNT film to obtain the T enriched region for an approximate ohmic contact. ZNT is intrinsically P-type, as reported by Safa Sultan, etc. IL4 with an zinc blend structure such as CDT. The high band gap value of ZNT is 2.26 eV and the valence band offset of 0.00 plus 0.05 eV with respect to CDT make it a suitable buffer layer materials. It is commonly to observe interdiffusion phenomena of some elements during technological process that are required for the fabrication of photovoltaic device. Thus, it is very affected the final efficiency of devices. An intersection An intersecting effect is the interdiffusion process between CDT and ZNT that forms a ternary compound CDXZN1 minus XTE, which might promote a wavelength response of the device to the solar radiation as well as better short circuit current density for. Despite the interesting result from the above mentioned works, none of them discuss in details any decrement of important parameters such as ZS, JSC, VOC and FF of their reported devices, which is the main contribution of this work. ZNT and TE thin films were grown on FTO, CDS, CDTE structures by using the closed space sublimation. The full form of CSS is closed space sublimation. Technique to obtain an optimal ohmic contact for photovoltaic device based on CDTE. First CDS, these films were deposited on SNO2. Limits subtracts FTO by the chemical bath deposition technique. A mixture of CDCl2 as per aqueous solution with a nominal molar concentration, a nominal thickness of 60 nanometer was obtained for CDS films. The CDS films were then thermally annealed at 450 degrees Celsius for 60 minutes under atmospheric pressure 6. The HT was complete by the deposition of the CDT thin film with a thickness of 4 cm in 3 minutes by the closed space sublimation. All CDT films were deposited with the source and substrate temperatures of 630 and 530 degrees Celsius respectively. Later, the samples were thermally treated with CDCl2 for 3 minutes. In order to get the TE-rich region over the CDT surface, we used two methods as mentioned in the introduction section. TE and ZNT deposition. In the first method, TE was deposited on FTO CDS. CDT substrate at a temperature of 400 degrees. FTO CDS CDT ZNT and FTO CDS CDT heterostructure were obtained and metallic contacts of Cu with a thickness of 20 ampere and 100 nanometer respectively were deposited in 0.078 centimeter to area. The structural characteristic of all samples were determined X-ray diffraction. The full form of XRD is X-ray diffraction. The X-ray spectra were obtained by an expert pro-MRD pananalytical X-ray system using the Puka line and a grazing incident setup. A set profiler Solon Decac was used to measure the layer thickness. The surface of the samples was observed using a scanning electron microscope. SEM dual series. Chemical qualification of elements were determined by using an EDS detector integrated into desktop with a spectral resolution of 129 eV and 0.001 CPS. Fixing window EDAX on 30 mm. ZNT compounds respectively. The K line and L line were used to detect the presence of CDTE and ZN. During this analysis, a work distance of 5.5 mm was employed for 5000 into magnification and 5007 mm for 50,000 into magnification. Ongoing research topics in CDS, CDT, photovoltaic. The full form of PV is photovoltaic. Device technology include development of a back contact demonstrating low resistance and stability while using process consistent with the large area. Manufacturing in effort towards this goal, we have developed a sequence of dry high temperature processes to provide this contact. The process eliminates the need for chemical electronic and is performed at 300 degrees to aid in the contact stability and applying this contact process to NREL. Devices which essentially 10% have also been produced using material supplied by solar cells in can by golden photons. To realize the full potential of PV solar cells based on thin film CDT issues. Relating to the fabrication of environmental stable, low resistance and readily manufactured ohmic contacts to PCDT must be addressed presently. Most containing techniques involves three process steps. First, a wet chemical treatment of the CDTE surface is used to produce a surface of reproducible stoichiometric that fills free unwanted deposits. The primary functions of the CIFL, the full form of CIFL is contact interface layer. Through the formation of a low resistance to serve this function must be. Third are outer metallization is deposited onto the CIFL. The metal provides an adhesive connection to the CIFL limits. On the other hand, for ZN5503 and ZN5505 samples, it was not possible to detect Zn atoms and the Te quantity increases with respect to CDTA. In both cases, it was such a small film that the electron beam passes through without being detected. For the samples, Zn atoms were detected as 4% and 2% respectively. The T amount also increases for the sample. These values are validated by XRD and SIMS measurements. In this case, SIMS is a capable system solve parts per million of a specific cable. A possible explanation is that when we deposit a binary compound such as ZNT, there is a competition of the two compounds over the surface form. Stable compound allows as the process. As of 2013, on a life cycle basis, the toxicity of cadmium is an environmental concern during production, and when the panels are deposited of some of this might be mitigate by recycling of CDT modules at the end of their lifetime. CDT technology in the midterm future, the abundance of tellurium of which telluride is the ammonium form is comparable to that of platinum in the Earth's crust and contributes significantly to the module's cost. The toxicity of cadmium is an environmental concern during production, and when the panels are deposited of some of this might be migrated by recycling of CDT. Uncertainties regarding the cycling of CDT modules 8 and 9 and the public opinion is skeptical towards this technology. The usage of rare material may also become a limiting factor to the industrial scalability of CDT technology in the midterm future. The evidence of tellurism of which telluride is the ammonium form is comparable to that of platinum in the Earth's crust and contributes significantly to the module's cost. Thank you.